Hi, I'm Jay. I'm here representing my team, Team Dragon, to present the project that we worked on over this semester for our software engineering class. The project is called Raise Hands. It's an online platform that intends to make the online interactions for students and teachers in digital classroom environments much smoother. The way it works is as follows. Students and teachers can create accounts on the platform, and teachers or students can create sessions that other students and participants can join in order to post questions and indicate that they want to ask a question or have something to say or things like that. And then after the session is done, teachers can get feedback from the students about how the session went. So to dive right in, I'll go ahead and show creating an account. So um, actually over here on the left hand side, I'm going to sign into an account that I've already created. And then the other three windows will treat as students. And so you can see that I've already got some sessions created for the account that I have already. I'm going to go ahead and register this student one. So we'll call her Maria, and she's successfully registered. We'll make student 2. Call him Sahith. Now over here, we'll go ahead and make another student account, and we'll call him Tyrone. And now all of the participants have their own accounts. So now I'll demonstrate creating a session. You can see once you've given it a name, it'll populate your sessions list and have a 9-digit join ID and a 6-digit passcode. And so anybody who wants to join has to enter in the correct join ID and the associated passcode. And these are cryptographically securely generated. And every single session has a unique join ID. So go ahead and join it. And as you can see, the interface has a bunch of data in it, namely at the moment, the join ID and session ID, or passcode, as well as the session name, and some options to start the session, and the participants list. So over here, I'm going to go ahead and add Maria to the session. And there is a minor bug here in regards to the real-time data through WebSockets, but I'll talk a little bit more about that later. So I'll go ahead and sign in another student, and I have to remove the dashes here. Now you can see that Sahith has showed up for the other participants. So I'll go ahead and sign in Tyrone as well now. So now everybody is signed into the session, and a student can leave the session and rejoin, and all of the information will be there, and rejoining a session doesn't cause their information to show up for other participants again. I can go ahead and start the session now, which displays the interaction box that allows students to go ahead and start posting interactions. So there's a minor issue, but going back to the connections thing, but the interaction was posted to the session, and I had to restart it to show it. I believe the reason why there are some issues with the real-time events showing up is that as the application is currently deployed, there are the WebSockets connection is tied to the actual server instance. However, in the hosted environment, I'm actually deploying 2 replicas of the application. So that could be one issue, is that some clients are connected to one of the servers while others are not. And so it's a load balancing issue. And further, uh, there could be some issues with the connection, and I don't have retry set up. So now I've gone ahead and started the session again to display the interaction box for students. and the connection issues persist for Sahith, unfortunately, but I'll be able to demonstrate uh, functionality regardless. So here you can see that the messages are able to propagate to all of the connected students. And this demonstrates the basic functionality of the application. So I'll go ahead and end the session, and we'll move into talking about the actual code for both the backend and the front end, and starting with the backend. Now, the backend was written in Java using the Spring framework, and here the architecture is pretty straightforward. We have the main entry point, which is the raise hands server application, and alongside that, in their own separate modules, we have essentially the feature modules. So we have things like the auth, feedback, interaction, and session. And these all are the main classification of the different use cases that are available through the system. And so to kind of highlight that a little bit, if we dig into, say, auth, um, you'll be able to see several different sub-packages that represent the main components that build the auth feature. So here we have the auth controller, and this essentially maps HTTP requests to various functionality in the backend. We have DTOs, which are data transfer objects, to take data of various types and transport them around the application in different contexts. So account DTO is the basic um, like account data holder, and we have other options like auth response DTO. The reason why these are used is because some specific data structures are required in different contexts. And here in the model, we have the actual account model. This is a representation of the data that's stored in the database. So it's an ORM, and we can add, so the data object has a bunch of fields that represent the attributes and columns in the database, and we can assign annotations to the fields to apply specific constraints. And then, of course, there are other um, tools and component types that we can use. So things such as repository, which sits above the model and allows the application to interact with models. Then we have services. And here, each service has an interface that describes the methods that are made available by the service. And then there's an associated implementation. And these are used by controllers. And you can see that all of the other feature modules have essentially the same structure with minor differences. So the interaction and session features make use of messaging for the WebSockets. Now we'll go ahead and look at the front end code and architecture. You can see that it has a very similar structure where we have app.js as essentially the entry point into the front end web client code. And we have essentially routing provided with a header and different types of routes. So there are authenticated routes and unauthenticated routes, and authenticated routes essentially mean that you must be signed in to be able to access that specific route. And as I mentioned, the feature module is essentially similarly structured as the backend. So we have auth, which is the entire vertical slice of authentication from UI to the front end API adapter service and other components. And all of the other features have a similar set of UI and front end client business logic components. Next, I'd like to highlight the auxiliary packages. So we have styles and we have util and common. Styles essentially just hold the application design. And in util, we have several utilities that are used throughout the application. So here we have HTTP, which is a wrapper on top of Axios, the library that we use to make backend HTTP requests from the front end. We essentially configure it and use HTTP as a facade or adapter type pattern. And then we have WebSockets, which is a higher order component in React that essentially provides WebSocket access to any component that is wrapped inside of its own UI tree node. And it's very useful because it provides a singleton-like reference to the WebSocket connection, which makes connection management much easier. Even though there are still bugs in the WebSockets connection, this makes it so that there can still be one reference to the relevant WebSocket connection. And then in each of these feature modules, they're essentially composed of views, which are the primary pages that contain the UI functionality. And these views contain subcomponents that represent specific pieces of behavior. So, and furthermore, the views also contain more complex business logic. So, using HTTP to get data from the backend through service calls, and essentially piping data to where things need to be. And so here on this line, you can see a specific example of making a service call. The service essentially wraps communication with the backend, even on the front end, so that the UI never has to think about what is required to communicate with the backend. Here's a few examples of some of the functionality that services offer. They're usually composed of building the correct URL and then making the correct request with the correct method, and then transforming the returned data into something that the UI can work with. Next, I want to demonstrate a pretty cool part of the project that we've set up, which is our deployment process. It's actually very simple. And to kind of give an example, let's say I'm not super satisfied with this header. I want to make it look a little bit nicer. Say, I think that I can turn it into the next Facebook, but I need it to look a little bit better. So I'll go ahead and change the styling. I just need to find the appropriate CSS class. So it's the navbar custom. So go ahead and find that in our CSS styling. There it is. And we'll just go ahead and give it a nice, let's say, blue value. Let's see. It's a little bit more purple, but we'll go ahead and do it this way. So now we have a great blue value. Come back over here. Looks perfect. I'm very satisfied. This is going to be the next billion-dollar company. So now I'm just going to go ahead and create a build. We'll say this is version 0.1.4-2. And go ahead and run the build script that will handle all of the bundling of the code, containerization, and deploying that container to, or registering that container to a specific repo, and then actually telling the Kubernetes environment to load that container. And that's it. That's all it took. It's now uploaded, and we can actually check to see if the deployment worked. As you can see at the bottom there with the front end, it's been live for 22 seconds, so successfully deployed. We could go ahead and actually see it live. So go ahead to the raisehands.io live application, and we can see that the change has propagated to all of them in real time. Very nifty. So this is our project. I hope you enjoy watching the demo. There's still much more to do, but I'm proud of the progress that my team has made. Thank you for watching.